Hello dear students, I welcome all the standard 7 students on this online classes. So previous classes already we have discussed about different types of motions, and related to that motions different examples also we have discussed, and the difference between that periodic and non-periodic motions also we have learned and discussed, and I hope all of you have understood that one properly. Today we will be going to discuss about simple pendulums and the terms related to simple pendulum. Okay, so without delaying, let's get started this one. So here on the screen you can see one figure is given, that one is the figure of a simple pendulum. Just I am going to explain about that simple pendulum, how to construct that one. Yes, so one rigid support will be there, which is the fixed one, and one string will be there, and one end of the string is fixed with the rigid support and another end is tied by the help of a bob. Yes, and that bob is oscillating from two different points, that is here A and B. So if we will try to oscillate that pendulum from A to B or B to A, then it start oscillating. Yes, so what will happen here? So one mean positions is there and two extreme positions are there. So here you can see that A and B are the two extreme positions and one mean positions is there, and that is when the simple pendulum is not moving anywhere, when it is in the state of constant, at that time that position is called as mean positions. Okay, now we will be going to discuss about that simple pendulum. Yes, so all the details about that simple pendulum we will be going to learn here. What is extreme positions, what is mean positions, how it is oscillating. Yes, so different terms also we will learn. So let's start that one. Okay, so simple pendulum. An ideal simple pendulum consists of a heavy point mass suspended from a rigid support by a weightless and inextensible string. So specially that simple pendulum is made up of one thread will be there and it is attached or suspended from a rigid support by a weightless and inextensible string. That string should not be extensible or it cannot be expanded. Inextensible string we will have to take, and one heavy point mass will be there. Okay, that one is called as bob of the simple pendulum. Yes, so but it is difficult to analyze it in actual practice. Thus in reality a simple pendulum consists of a heavy bob suspended from a fixed point, one fixed point, that is the rigid support will be there. Yes, and from that rigid support that string will be hanging and another end of the string is tied by a bob. Okay, and inextensible thread will be there. The rest positions of the bob of a simple pendulum is called its the mean positions. If it is not moving anywhere, if it is constant, then that position is called the mean position of the simple pendulum. Okay, the positions O in figure 2.13 we have seen that one, when that one is the mean positions, that one is the mean position of the bob, and when the pendulum moves, when we will try to displace that simple pendulum, at that time obviously it will be moving on either side of that mean positions. So either side of that mean positions, two extreme positions we will get. So what is that extreme positions? Let us see. So when the pendulum moves, it is said to be in oscillatory motions. That motion of the simple pendulum is called as oscillatory motion, we know that. And the positions of the bob at the maximum distance on the either side from mean position is said to be at extreme positions. So from the extreme positions again it will come back to the mean position, and from that mean positions to the another extreme positions, and from that extreme position to the again it will come back to the mean position. So the maximum distance on either side of the simple pendulum from its mean position is called as extreme positions. That means from where that bob is coming back to the mean position, that one is called its extreme positions. So in that figure, A and B are the two extreme positions, we have seen that one, and a simple pendulum which has a time period of 2 seconds is called a second pendulum. So about that time period also we will discuss. Yes, so just you try to remember this one. If a simple pendulum which has a time period of 2 seconds is called a second pendulum, okay, and the length of the second pendulum at a place where g, that is acceleration due to gravity, is equal to 9.8 meter per second square, is nearly 1 meter. That means the length of the pendulum is 1 meter and the time period is 2 seconds. Then it is called as second pendulum. A second pendulum is independent of amplitude and its frequency is 0.5 hertz. So different new terms are here, that is amplitude, frequencies, time periods. Yes, that one we will be going to learn. Okay, so the terms related to a simple pendulum. Let us see about the different terms which we are going to use in case of simple pendulum. First one is the oscillation. So if it was present, that simple pendulum was present in the mean positions, if it is not moving anywhere, then push the bob from its mean positions to one side gently. Just we have to displace the bob or move that bob to one side gently. In figure 2.13, that previous figure, the position of the bob from O to A to B, and then back from B to O is one complete oscillations. That means from wherever it will start, again it will move and come back to that positions, then it is called one complete oscillations. Okay, if we consider from the mean positions, then from the mean positions, left hand side extreme positions, then from that left hand side extreme positions goes to the right hand side extreme positions and again come back to the mean position, that is one complete oscillations. Or also we can define this one as from one extreme positions to another extreme positions and again from that extreme positions to that initial extreme positions, then that one is called as one complete oscillation. So therefore one complete oscillation is the displacement from the mean positions to one extreme position to another extreme positions on the other side and back to its mean positions again. So from where that motion start, again it will come back to that mean positions, then go to the another extreme position, again come back to the mean position, is called as the complete oscillations. Okay, I hope all of you have understood that one. Then amplitude of oscillation. So the maximum displacement to which the bob moves from its mean position is known as the amplitude of the oscillations. So from the mean positions, if you will see the extreme positions, that maximum displacement to which that bobs move from its mean position to the extreme position, that one is called as the amplitude of oscillation. In that figure, OA and OB is the amplitude of the simple pendulum. Okay, then time period. Yes, at that time while we were discussing about that second pendulum, at that time I said we will be going to learn about that time period also. So let us learn about that time period, frequency and length of a pendulum also. So time period, the time taken by the bob to complete one oscillation is called its time period. Yes, so how much time it is taking to complete that one oscillations, all of you have understood that one, I think, that to complete one oscillations, how much time it is taking, that one is called as the time period of the simple pendulum, and it is denoted by the letter capital T. It is measured in second because this one is time period, so obviously the unit of time period is second only. Yes, so maximum time or how much time it is taking to complete one oscillation is called the time period. Then the next one is the frequency. Okay, Frequency means what? The number of oscillations completed by the bob in 1 second. So in 1 second, how many complete oscillations occur while that simple pendulum is moving or oscillating? That one is called as frequency. So the number of oscillations completed by the bob in 1 second only. In 1 second, how many number of oscillations completed one is there, that one is called as the frequency of oscillation, and it is denoted as N or F, and its unit is Hertz. Hz is the unit of frequency. Time period and frequencies are related with one another. One relations is there by the help of which that frequency and time periods are related to one another. That is, frequency is equal to 1 divided by time period, or by doing the cross multiplications we will get time period is equal to 1 divided by frequency also. Yes, I hope all of you have understood that one. Then length of the pendulum. The length of a pendulum is the distance from the point of suspensions of the pendulum to the center of the bob. Its SI unit is meter only, because length is measured in meter. Yes, and SI unit of length is meter only. Yes, so length of the pendulum means from where it is suspended, that means from the rigid support to the center of the bob, because spherical surface we have taken, one solid sphere we have taken, that one is called as the bob only. Yes, and you know that one sphere is also having one center. Yes, so the length of the pendulum is the distance from the point of suspension of the pendulum to the center of the bob. Then that one is called as the length of a pendulum. Okay, and its SI unit is meter. Okay, so I hope all of you have understood that one, whatever we have discussed. Again, I am going to explain about that figure. Here you can understand more properly. So from O to, see here, O is the mean positions. From O to A, that one is the A and B are indicating the extreme positions, and O to A and O to B is the displacement. Yes, is the displacement of the pendulum, that is called as the amplitude of oscillations. And then one oscillations means, here you can see that one O to A, then again A to B, then again B to O, one complete oscillations. One rigid support is there, string is there, then bob is there. That length of the simple pendulum is from that rigid support to the center of the bob, it is called as the length of a pendulum. Then frequency, the number of oscillations completed by the bob in 1 second. How many number of oscillations is taking place in 1 second only, that one is the frequency, and it is measured in Hertz. Time period, time taken to complete one oscillations is called as time period. Then amplitude of oscillations means the maximum displacement from its mean positions to its extreme positions, that one is called as amplitude. So in this figure, OA and OB is the amplitude of the pendulum. Okay, then one oscillations, complete one oscillations. So the position of the bob from O to A, then A to B, and then back from B to O is one complete oscillations. Okay, I hope all of you have understood this one. This much only. Again, you must go through your book also. Thank you.